Welcome to Math Line this afternoon, and who am I talking with?
Hi, Ernie. This is Joe.
Joe, good to hear from you again, sir. How are you?
Pretty good. Been a long time.
It has. It has been a long time. It's not been an easy time for a lot of us, I'll tell you out there. So, what's going on in your world? How are you doing? And by the way, where are you calling us from? Refresh our memory, including my own.
I live in Bearden.
Okay, all right. Well, great to have you with us.
But I'm right now at the Williamson Golf Course. I just finished hitting the ball.
Man, you got it made. That's awesome. That is great. That is great. Well, have you got a problem of some sort for me here today?
Yes, sir. I have a quadratic equation I want to ask you. That won't be hard for you. It's 5x squared plus 2x plus 1 equals 0. And my main concern here is when you have to square a negative number.
Okay, did I get it right here? 5x squared
5x squared
plus 2x plus 1 equals 0, correct?
Right.
All right. What I'm going to do first, Joe, I'm going to put this thing on. Let's see if I can get a y equals going here. Let me knock out a few of these y equals that we've had here from the past. Some of our graphs from the Forest days. Let's see. And what I'm going to do first, I want to show something to our viewers and to you also that will give us some ideas that this is going to act a little interesting. It's going to act not a little, it's going to be very interesting. It's going to act a little differently, though, than we might have expected. And what we're going to look for is where it crosses that x-axis. That's going to give us our answers, okay? So far, so good? And let me graph this.
I don't even know how to do the b squared minus square root of 4ac, which is
Okay.
divided by, I can't remember.
Okay, hold on.
Divided by 2a.
I got you. We're going to have to go there. Let me get a zoom 6 on. Let me tell you why we're going to need to go there. On my graph here, if this does not cross, and I've got a nice pretty red parabola here. I don't know if you can see it there where you are. If you're at the golf course, you may not be thinking about it, but it did not make it to the x-axis, which means we're going to be looking at complex and probably some imaginary situation of roots, which means we're going to have to go the quadratic formula, all right, to find where this is. Because what this does is basically we're looking for the roots, or we're looking for the solution, and they're going to be in imaginary territory. So here's what we're going to do. I'm going to use that quadratic formula. I'm going to give it to you. And it says x equals the opposite of b plus or minus, and you were mentioning the square root of b squared minus 4ac all over 2a. And to our viewers who have not had Algebra 1 or Algebra 2, you're going, what is that about? All right? That, my friends, that's the quadratic formula. And the reason I'm going to do this, because I can tell it's not going to factor, and I'm not going to have real roots. In other words, these are going to be what we call complex, imaginary, all sorts of different titles that can go to them. But we're going to have a very odd-looking creature here. This is how we deal with things that aren't real. And already you're going like, everything's not real in math? No, not everything is real in math. I'm sorry, but we have imaginary numbers, we have complex numbers, which involve a real plus a complex part. So I think we're going to be looking at probably the complex situation here. I don't think it's not going to be a pure imaginary. I know that. So let us see where this is going to go. First of all, let's talk about what ABC is. A is the value attached to x squared. So we're going to put 5 in there, all right? We're also going to let b be the coefficient or the number that is sitting next to our x in the middle, our linear term we like to call it. So b is 2. And then c is our little number out here, constant. We'll say c for constant, how's that? And it's also by itself, but it's going to be our c for the formula. Now, Joe, what we're going to do, we're simply going to plug these numbers in. I like to say we're going to plug and chug, all right? And that's what's going to happen on this. We're simply going to put in B, A, and C, and we're going to see some interesting things happen. Okay, so hang with me on that. Are you good so far? You understand what I'm talking about?
Pretty much, yeah.
Okay, so at this point, it's the quadratic formula. I used to teach my students when I taught this in Algebra 1, we can sing it to Frere Jacques. Opposite B, plus or minus radical, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. It was a quick way for them to learn it. They kind of liked that. And there are others, somebody else has something called My Bonnie Lies Over the Ocean. I have no idea how that one worked. It was just a little too complex for me. Frere Jacques, Are You Sleeping? Worked great. So let's put some numbers in here, as I said. Plug and chug, and everybody's going like, are you going to sing anymore? We're going to shut the TV off, aren't we? Let's put some speed in here. Now, this is not really negative B. Notice, when I sang the words, I said opposite B. If B had been a negative 2, we put a positive 2 in there, Joe. That's the idea. And it's not, so we're going to put a negative 2 right in there and start working with what's going on underneath our radical. Our B squared is 2, and we're going to square it. All right, so we're going to put 2 squared. I'm going to put that under the radical. Minus, here comes the big stuff. Minus 4 times, goodness, what did we get? Well, we got a 5. And we got a 1. So there we have it. There we have where we're going. Oh, we got to have a denominator too, don't we, Joe? So let's put a 2 times 5 down there. So what I did in the audience and out there viewers, I simply put a 2 everywhere I saw a B. I put a 5 everywhere I saw an A. And then I popped in a 1 for everywhere I saw a C, which was only one place there. So far, so good?
Yep.
Just use the formula, put the numbers in there. So here's what's going to happen. I'm going to get into, goodness, what am I going to get here? I'm going to get a negative 2 plus or minus. And here's where the fun becomes. We got a 4, and we're going to have to subtract 20. Now, underneath, I get 10. So the 2 and the 10 are easy. Here's where things get interesting. We're trying to subtract 20 from 4, which leaves us with what? Negative 16. Am I right on that?
Yeah.
So we got this negative 2 plus or minus the square root of a negative 16. Now, this is where we get our minds blown in Algebra 2 class occasionally. We're going to try to be good about this, okay? Not to make it too hard. But you can't square root a negative number. Because a square root of a negative number, well, a negative 4 times a negative 4 comes back to positive, doesn't it? And a positive 4 times a positive 4 comes back to positive 16. We've got to get a negative 16. So this is where we enter this territory of imaginary numbers. We're trying to take the square root of negatives, and there is a way out of this, okay? And that's where I talk about complex numbers. So hang on to your hat. We're almost there. We're going to keep the plus or minus because it's a double root situation. We've got 2 different things. And by the way, this little number underneath here, we call it the discriminant. And if it's negative, it means we got 2 roots, and they are going to be complex. And they could be imaginary depending on what B is, but this is going to be a complex because we didn't get rid of B. So we got negative 2 plus or minus, and here's what I'm going to do. I hope I still got written. I'm going to do this I'm going to put this negative 1 times 16. We're going to bring I into our picture here. I was just jumping the gun, my friends. So here's what's going to happen. We can do a square root of 16. So I pulled out. But I've got this negative 1. This is where we got to worry about what is going on there. So we have a negative 2 plus or minus this square root of negative 1 times the square root of 16. I want to write that down just because it came out pretty messy up there. It looks kind of nasty. There's not an I yet. That's coming. Over 10. The negative 2 and the 10 are fine. We're not going to worry about those. The root of 16, what's the square root of 16? It's 4, right?
Yes.
All right. So what we got to do is figure out what is the square root of a negative 1 in our little world. And remember I said word imaginary. So here's what's going to happen. We get negative 2 plus or minus. We're going to go ahead and put the 4 out here. And Joe, I up here, oh no, that's under me. I'm going to go ahead and put it. I is equal to the square root of -1. That's our unit. It's an imaginary unit that we have. It brings us into a whole new realm of mathematics. We'll put the I next to the 4. Keep it over the 10. I notice there I've got 1, 2, 3 business pieces here, all right? And what that's going to give me is that we can divide everything by 2. All these are even numbers. So I'm going to go -1 plus or minus, so it's like 2i, and place it over our 5. Then you say, Ernie, what does that mean? Because there's our solution. But what that means is we're going to take this -1, we're going to add 2i, and we'll divide it by 5. That's one of the roots that we could not get on our graph, if you remember. And the other one is going to be -1 minus 2i over 5. And again, it's just a way that we get into what we call the complex number arena. And there's subsets, there's real, and then there's the real numbers, there's the imaginary numbers, and there's the whole, it becomes a whole part of the whole complex system. But those are our 2 solutions there. So that's why the quadratic formula becomes very important. If it had factored, this thing would have landed our graph. Can we go back to the graph, guys, just a second? If we factored, we would have landed somewhere on probably an integral value or something that would be rational. Okay, definitely would be a rational situation. We might have to use a quadratic formula on it, but had we been able to factor it, probably we would be landing on some nice integer values, and life would be great. You could say, oh, x equals 2, or x equals -2, maybe 5 over 2, maybe something crazy. But we can also get square roots in there when the discriminant is not going to be working out to be a perfect square. Now, we had a perfect square, unfortunately, it was a negative attached. So that was the big difference in that. Let's go back to our problem here one more time. And that's why we split away the 16 and did the -1, so we could go ahead and figure out what 16, that was easy to do. We just leave an I with the -1. It's sort of like, and by the way, we didn't want to add -1 plus 2, because those aren't like terms. One's a constant, one's got an I attached. So that's why we didn't come back and say, oh, well, that gives us I over 5. Do you see that, what I'm talking about there?
I'm not watching, so I got to go home and see the recording.
Okay, all right, we'll get there. And then you can't do the 1 because you're dealing with things that are not like terms. All right, so, but in other words, once you get the I concept into your head, which is usually algebra 2, when they catch this in algebra 2, and it's kind of crazy. It's like you have imaginary numbers, sort of like your imaginary friend, maybe. It's not really, but it really does help out. It keeps you on track, okay? So I'll leave it at that, and hopefully you can come back and see the taking there. But that's what, folks, that's what the algebra 2.
So is the answer x equals -2 plus or minus 4i divided by 10?
Yes.
Which would be -0.2 plus or minus 0.41.
You could do that. Yeah, you can make that in. I just kept it as an improper, kind of a fraction setting and stuff there, since the quadratic formula. But yeah, you could make the 1/5 into 0.2 and the 2/5 into 0.4. Absolutely.
Yeah, I'd like to see really how you put it on the graph, but I don't want to take up all your time.
Oh, that's okay. And like I said, you can see the problem is if the graph does not cross or get to the x-axis, like we got here, and you'll see this when you look at it again. There, my friend, that means our roots are into complex or imaginary situation, depending on how our A, B, and C fall. Okay? And that's your story for today.